Friday, this is due. Your little extra credit posters. You don't have to do it, but if you do, it's due Friday. Tomorrow, Friday. Okay. You can graph this in your yellow calculators and do menu 5.1 to get these values, everything here. So let's do that. On new document number 2, sorry, don't save, and then number 2, add a graph. So everyone's been able to graph this in your yellow calculator. Okay. Do you have a yellow calculator? Hey, do you have a yellow calculator for your quiz? Okay. Oh, well, I do. I just don't see all his names on these recordings. Right, student? All right, now, here we go. I graphed it. I can see part of the graph. I can't see the top of it. Okay, I can't, and it keeps going down forever. But how do I get the vertex? What buttons do I press? No. No. Menu 5.1. Now, when you hit menu 5.1, it's going to pop up with this point, and if I go left and right, it tells me this is the what? What is this point? The y-intercept. It's going to tell you what it is, y-intercept. And at the bottom, it is 0, 9. So we can put that for the y-intercept. But I need to go up to the vertex. So remember, when you're doing menu 5.1, you shift left and right, not up and down. Okay, so we go to the right until I get to the vertex, and there it is. What type of vertex is that? Maximum. Okay. And in the vertex, it tells me that maximum is 1, 12. That's my vertex. Now, I need x-intercepts. So once again, you're tracing. You go left or right. So I'm going to go all the way to the left till I get to this. Oh. Now, this doesn't say x-intercept. It says 0. But don't we know that 0 is the same thing as x-intercept? What's another name for an x-intercept and a 0? 0, x-intercept. Root. Solution. Have we gone over those 4 names before? Yes. Roots, zeros, solutions, x-intercepts are all the same thing. So when it says 0, you know that means x-intercept. It's negative 1, 0, so you can write that down. And then what's the other root? I can go all the way to the right. And it is 0, 3, 0. So you see how I have 2 x-intercepts. I got to put 2 separate coordinate points. Okay. Okay. Now, axis of symmetry is always what? Axis x equals. Now, I don't have like a graph to draw on, but I know it's x equals the x value of the vertex. What's the x value of the vertex up here? 1. Okay. So x equals 1. If you weren't sure on your calculator, you can go up to the top and see, hey, well, the x value here is 1. Okay. Now, domain and range. We talked about this yesterday and Monday, and say it again. For a quadratic, it goes forever to the left and forever to the right. So what do I put for the domain? All real numbers. You could also put negative infinity to positive infinity. It means the same thing. But the range is not always the same. So how far down does this go if it keeps going down, down, down forever? Negative infinity. It goes down to negative infinity. But how far up does this go? What is the y value of that vertex? So again, the vertex, the y value right here is what? 12. You'll see that right here? The highest it goes is that vertex. It's a maximum. The y value is 12. So here's how you can write it. Down forever is negative infinity with a parentheses, comma, the highest is 12 with a bracket. Okay, that is not unlike what we did yesterday on the quiz and the warm-up. This is stuff you can do if you have an equation. You can put it in the calculator, menu 5.1, get these values, okay? If you have a graph, you can get this stuff off the graph, okay? Now, we do got to press forward today, so we're going to do 4.2 notes on factored form, okay? And then tomorrow we're going to do 4.3. I know. So I got to show you how to do it. I got to show you how to do it before you can do it. And tomorrow we have 4.3, but then on Monday, which I know is some kind of weird day, I'll give you some extra time to work in class, okay? You should come. All right, so I'm going to pass this out, and we're going to get started on these notes, so give me a second. Okay. Quadratic factored form. Earlier this week on Monday, we were talking about vertex form, okay? If you're given the vertex, you can plug it into that form we talked about yesterday and Monday, okay? But today we're talking about this factored form. It's also known as root form. Now the first couple slides are going to be just some review, right? So what I'm about to show you, you don't have to write down. Just look up here, okay? First things first. Y'all know that this is the parent function because parents are basic. They go through the origin. They don't stretch or compress. They don't shift or anything. They're just right there in the middle, okay? That's the parent function x squared. It's also known as a parabola. Have y'all heard that word before? Okay, quadratic U-shapes are called parabolas from now on, okay? So, quadratic functions, let's see here. Yeah, there we go. Move that up a little bit. The highest or lowest point is called the vertex. We know this already. We know the bottom is a minimum. We know the top is a maximum. We already know this stuff, okay? We also know axis of symmetry is always x equals whatever the x value that it goes through. We already know this. This is old news. We also know roots go through the x-axis. Check it out. These are the four names that are all the same. Roots, x-intercepts, solutions, and zeros. We know they're all the same phrase, so we use them interchangeably sometimes. And then check this out. If you have two roots, doesn't this look like it crosses twice across the x-axis, these blue ones? Those are two roots. Now, what if it looks like this graph where it touches only once? That's called a one root, but you really call it a double root. I'm going to show you on example 3 today. What do you do with the double root, okay? Now, the last example we're not going to see on the assignment, but sometimes it doesn't even cross at all. Okay, that's a no real root. You don't use the root form or the solution form, factored form, unless you have at least one root, okay? Now, this is the form we used on Monday. If you have h and k, the vertex, you can plug it in, get your equation. But here's what we're doing today. What's that root on the left? What number is it? 6 is the one on the right. What about the left? 2. Do you see that the equation has insiders? And we know insiders do what? They lie. So instead of putting a positive 2 and a positive 6, we're going to put -2 and -6. Do you see how those roots go into those parentheses and insiders lie? That's pretty much what you're doing today. The only other thing you need to do is count the rise over 1 for the a value, which I'm going to show you exactly how to do it right now. So everybody, look at example 1. Pay close attention without headphones or phones in your hands or in your ears or in your hands or on your desk. All right, here we go. Does this okay, before we do anything, do y'all see over here off to the right? For you, it's on your left of your paper, okay? This is your notes. Let's look at it. Step 1, to figure out scale factor A. Do y'all remember on Monday we said you have to find the rise over 1. I know it's kind of weird. When you're doing rise over 1, that'll give you your scale factor when you start at the vertex. We did that on Monday. We're going to do it again today. I'm going to show you how to do it, okay? But you need to figure out the A value, the rise over 1, from the vertex. Step 2, you put the roots in and write this down. Insiders lie. So I want you to write both of those things on the left side of your paper, okay? Step 1 is rise over 1. Insiders lie for step 2. Okay? Everyone getting this down? Unless you're quizzing, do your quiz, right? Doing your quiz? Doing your quiz? Finish. Who else doing a quiz? Finish. Wait. Doing your quiz? No. Oh. I didn't give it to you, right? Oh, you gotta do corrections later. All right. Here we go. Does this open up or down? It opens up. All right, write that down. Because it's going wider, forever, up and up and up and up. Now, scale factor. This is very important. Is everyone looking in? Okay, scale factor is your A. It's your rise over 1. Okay, so I'm going to pick that bottom vertex, and I'm going to pick the one to the right of it over 1, and I'm going to count what's the rise over 1. Now check it out. If it goes up, it's a positive number. But if it goes down, what kind of number is that? Negative. So if the graph opened down, it would be negative. If A is greater than 1, it's a vertical stretch. If A is less than 1, it's a vertical compression. Things we know from the last section we did. Well, let's count this scale factor. So starting at the vertex, how much does it rise? 2. How much does it run? 1. Does everyone see how to get the A value? You start at the vertex, rise over 1. So this is 2 over 1, which is the same thing as a regular 2. Anytime you divide by 1, you just get a whole number, right? Dang. Out of reach. All right, now, what are my roots? So this root on the left, what are the coordinates of this root right here? 0, 0 is this root on the left. It's where it crosses the x-axis. 0, 0. What about this root on the right? 4, 0. Okay. Do you see how it crosses twice? I have 2 roots. Okay. Now, axis of symmetry is always x equals, and you can draw that line down the middle. What is this x value of this vertex? So by the way, this vertex is 2, negative 8, if you didn't get that. So my axis of symmetry goes through the middle at 2. Do you see how the vertical line touches 2 on the x-axis? X equals 2. Now root form, above root form, I want you to write y equals a x minus z1 x minus z2. And then all we gotta do is plug in a and my 2 roots. So what is my a value? We got it up here, it's 2. Now I'm gonna put x, and then remember, insiders lie. What's the opposite of my first root? Well, it's a 0, so minus 0 plus 0, same thing. Okay, it's weird when you have a 0, I'll be honest. And then on the other parentheses, x, and then again, insiders lie. What's the opposite of this positive 4? Minus 4. Okay. Do you see how I got a? Rise over 1, and then the roots, make sure they're opposite. Wait, did you finish that quiz? Do the quiz, don't do this. You have to catch up on this later. So, here's the deal. X minus 0, if you take away nothing from x, it stays x, right? So this is just x, and put the 2 in front of it, so it's really 2x, x minus 4. Which one? Line through it is a z. I'm trying not to confuse 2's and z's and 5's and s's, and they're all the same thing. Now, that's it. The hardest part is maybe counting rise over 1, remembering that insiders lie, but you should be able to give me an equation. Okay. Let's do example 2. Who still needs this? Who still needs it now? What about now? All right, example 2. I guess I could have just PowerPointed this thing. All right, which way is this opening? Which way is it concave? Down. It's going down, down. Okay. Now, what is my scale factor? So put your point at the vertex, and I'm asking, how does it go? How much does it go up or down before it goes over 1? So it's not even a whole unit. It's right down in the middle, which is 1/2. Okay, this is the weirdest one. When it's not a whole unit, it goes down a half unit before it goes over 1. And since it goes down, what kind of number is that? Okay, does everyone know down is negative? So if it's down a half over 1, then the scale factor is down a half, down 1/2. Okay. What are my roots? What is this root over here? -1, 0. What about this other root over here? 7, 0. So I got 2 roots. I have a scale factor. So real quick, axis of symmetry, if I drew it down the middle through the vertex, it would be x equals what number? 3. X equals 3. And now again, root form, y equals a x minus z1 x minus z2. What do you think I'm going to write for my equation? Y equals what? Before that, what's the a value that we got up here for our scale factor? -1/2, because it's going down. And then remember, insiders lie. So instead of -1, I put x plus 1. Instead of +7, I do x minus 7. Do you see how these insiders lie? And then this number in front is the rise over 1. Finish? Okay. You finishing on that quiz? Okay. You finished? Okay. You finished? One more. Now, example 3 is the weird one, okay? How many times does example 3 touch the x-axis? Once. Okay, this is what we call a double root. I'm going to show you how to do it. This opens up, right? What is my scale factor? What's the rise over 1? 4 over 1. So my scale factor is 4. What are my roots? So where does it touch the x-axis? Where does it touch the x-axis? -2, 0. And that's it. Now we need 2 roots, but we only have 1. So this is what we call a double root. Go ahead and write that down. No, it doesn't touch here. Yeah. So here's what you're actually going to do. You're going to use the same root twice. -2, 0 and -2, 0. Basically, use it twice. Okay. The axis of symmetry goes through that -2. X equals -2. And here comes my root form. Ready? A is 4. And my root, the opposite of -2 is +2, but you must write it twice if it's a double root. So again, if you have 1 root, you're going to write it twice. When you get to this 4.2 assignment, number 2 has 1 root. So you can look at example 3 on how you do it when you have 1 root. You put the same root twice. I said it, I wrote it, you have it on your page, you see it, hopefully. Okay. Now I'm going to pass this out, but if you haven't finished 4.1, you can finish that first before you crack on the 4.2, okay? But I am going to pass this out, we're going to get started, but the main thing I need is those quizzes first. So let's get started.